Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 26. Probability. A coin, a die, a shuffled deck, chance seems lawless, and yet it obeys precise rules. Probability turns uncertainty into arithmetic. The chance of A or B adds. The chance of A and B multiplies. And a fresh piece of evidence can flip the odds entirely. Through Bayes' theorem. Master the addition and multiplication rules. Learn to read a probability tree, and even the trickiest conditional problem becomes a calculation. Today, events, conditional probability, Bayes, and the binomial. One idea at a time. Here is what you will master today. First, sample space, events, and the addition rule. Second, conditional probability and the multiplication rule. Third, independence. Fourth, total probability and Bayes' theorem. And fifth, the binomial distribution and random variables. One idea at a time. 4 ideas. Run this whole chapter. Look at them together first. Probability. The chance of an event always between 0 and 1, and for equally likely outcomes, it is the favorable outcomes over the total. The addition rule. P of A or B equals P of A plus P of B minus P of A and B. The multiplication rule. P of A and B equals P of A times P of B given A. Master line. The addition rule is for OR. The multiplication rule is for AND. Now look at the picture. The sample space and 2 events. Sample space. It is the set of all possible outcomes, and an event is simply a subset of it. Union A or B is everything in either circle, and its probability is P of A plus P of B minus P of A intersection B. Intersection. A and B is the overlap. We subtract it once so that it is not counted twice. Mutually exclusive. If the circles do not overlap, then P of intersection B is 0, and the probabilities simply add. Now conditional probability and independence. Conditional. P of B given equals P of intersection B over P of the probability of B given that it has already happened. Multiplication. Rearranged. P of intersection B equals P of A times P of B given the AND rule. Independence. A and B are independent if P of B given equals P of B, and then P over intersection B is simply P of A times P of B. The test. Independent events multiply directly. The outcome of one does not affect the other. Now, a powerful tool, the law of total probability. A partition. Split the sample space into disjoint cases, a 1, a 2, and so on, that together cover everything. The formula P of E equals the sum of P of AI times P of E given AI summed over all the branches that lead to E. The picture. It is a tree, 1 branch per case, each weighted by its prior probability. When to use it? Use it when the event E can happen to several exclusive roots. It sets up Bayes. The total probability is exactly the denominator in Bayes' theorem. Now look at the picture. A probability tree. The tree. The first stage picks a case, or 1 or a 2, and the second stage leads to the event E. Multiply along a path. The probability of a whole path is the product of its branch probabilities. Total probability. Add up the paths that reach EP of O1, P of E given O1, plus P of O2, P of E given O2. Bayes' theorem. To go backwards, one single path over the total gives P of a 1 given E. Now Bayes' theorem and the binomial distribution. Bayes' theorem. P of AI given E equals P of AI times P of A given AI over P of E. It reverses the conditioning. Prior and posterior. The prior P of I is updated by the evidence E to become the posterior pi of I given E. And a variable, a number attached to each outcome, and it carries a probability distribution. Binomial for M independent trials, each with success probability P. The probability of R successes is NCR times P to the R times 1 minus P to to the n minus r. Mean and variance. For the binomial, the mean is np and the variance is np times 1 minus p. Now the formulas that earn marks. The addition rule. P of a union B equals P of A plus P of B minus P of A intersection B. Conditional probability. P of B given A equals P of A intersection B over P of A. Bayes theorem. P of I given E equals P of I given I over the sum of P of ij, P of E given ij. Now match each expression to its rule. P of A plus P of B minus P of A intersection B goes to the addition rule. P of times P of B goes to independent events. The sum of P of I times P of E given I goes to total probability. And NP goes to the mean of the binomial. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. For independent events, P of A intersection B equals P of A times P of B. Correct. Statement 2. The probability of any event can exceed 1. Wrong. A probability always lies between 0 and 1. Statement 3. The mean of a binomial distribution is n. Be correct. So the answer 2 are correct. Statements 1 and 3. The trap is the out-of-range probability in statement 2. Now the 2 mistakes that quietly cost marks. The truth, for independent events, the probabilities multiply directly P of A times P of B. The trap, confusing mutually exclusive with independent, exclusive events cannot both happen, and so they are not independent. The second truth, Bayes' theorem, reverses the conditioning, using the total probability as its denominator. The second trap, forgetting to subtract P of A intersection B in the addition rule for OR. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The addition rule, P of A plus P of B minus P of intersection B. Question 2. Conditional probability, P of A intersection B over P of A. Question 3. For independent events, P of A intersection B, P of A times P of B. Question 4. The mean of a binomial, NP. And question 5. Bayes' theorem reverses what? The conditioning. Let us gather it all in one breath. Probability lies between 0 and 1, favorable over total. The addition rule for OR, the multiplication rule for AND. Conditional, P of P given A, and independence means direct multiplication. Total probability, a sum over a partition, and it sets up Bayes. The binomial NCR, P to the R, times 1 minus P to the N minus R, with mean NP and variance NP times 1 minus P. Next class, statistics, the mean, the median, the mode, and dispersion. Chance is not chaos. It is arithmetic in disguise. Add the probabilities for OR, multiply them for AND, condition on what you already know, and let Bayes turn evidence into an updated belief. Draw the tree, weight each path, and even the most tangled conditional problem unravels into a sum of products. Master these rules, and probability stops being guesswork. Next class, we turn from chance to data, statistics. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.